Hello, good day viewers. In our previous lesson, we have learned how to convert non-terminating but recurring decimal numbers into fractions. But I told you we have other forms of non-terminating recurring decimal numbers. Example, if we have a number 0.0777 in that order. If you observe, we have a number 0 before what? That 7 that keeps on repeating. So how can we convert a decimal number like this into fraction? That's what we are going to learn in this tutorial. Alright, what you should know is that this number is the same thing as 0.777 recurring, but what? Divide by 10. If you take this number, you divide by 10, you're going to get this one. But in our previous lesson, we have learned how to convert this type of decimal number into fraction. And I told you, you should just take that number that keeps on what? Repeating, which is 7. But it is a single number that keeps on repeating. So you divide by a single 9. If it is two numbers that keeps on repeating, you divide by 2 9s, 99. But don't forget to divide by 10. Dividing by 10 is the same thing as multiplying by 1 divided by 10, right? Just multiply the 9 by that 10. And this is equal to 7 divided by 90, right? And if you take your calculator, divide 7 by 90, you're going to obtain a number 0.0777777 in that order. Let's take another example. What if we have 0.0063 recurring? It is only 63 that keeps on repeating, but we have other 2 zeros before 63. So how can we do this? We can say that this is the same thing as 0.63 recurring, but divide by 100 because we have 2 zeros before 63. The numbers that keep on repeating are what? 6 and 3. Bring them here. 6, 3. But since they are 2 digits, you divide by what? 99. But don't forget to divide by this 100. All you have to do is to multiply the 99 by 100. So this is equal to 63 divided by what? 9900. I think this can be reduced because 3 can go here. How many times? 2 times. And 3 can go into 3 1 time. You divide by 3 into 9 is 3. 3 into 9 is 3. 3 into 0 is 0, 0, right? Still, we can reduce this because 3 can go into 21 7 times. So this is equal to 7. Divide by 3 into 3 is 1, 1, 0, 0. Therefore, 0.0063636363 is the same thing as 7 divided by 1100. Just take your calculator, press this, you're definitely going to get this. But the question is, what if we have other numbers here apart from 0, 0? Let's find out. For example, suppose we have a number 0.3444444 in that order. You see we have a digit 3 before the recurring digits. So how can we combat this? It is as simple as saying this is the same thing as 0.3. This 0.3 plus 0.044444 that keeps on repeating, right? But we have just learned that this is the same thing as 0.44444 divided by 10. So we have 0.3, right, plus 0.44 that keeps on repeating, but divide by 10. We know that this is a terminating decimal, and we have learned how to convert terminating decimals into fraction. How many times do we need to migrate this point to the last digit? Is 1, so you divide by 10. So this is the same thing as 3 divided by 10 is the same thing as 0.3 plus, this is the recurring. What is recurring here is 4, only one digit, 4. Divide by what? 9, don't forget. But what? Divide by 10, which is the same thing as multiplying 9 by 0, right? So you have 90. And we can simply add this because the LCM is going to be 90. 90 is the number which 10 and 90 can go into without remainder, and the smallest number. There are other numbers, but this is the lowest common multiple. 10 can go into 90. How many times? 9 times. And 9 times 3 is 27. So we have 27 right here. 90 into 90 is 1. 1 times 4 is 4. 27 plus 4 will give us what? 31, right? So this is 31 divided by 90. Is there anything that can divide? I don't think so. So 31 divided by 90 is exactly the same thing as 0.344444. Let me take the last part, which in case we have a number other than 0 as our whole number. Let me take simple number 1. All other numbers are the same. So if we have 1 point, let me take 3 for example. 4, 4, 4. This is just an example. It is only 4 that keeps on repeating here. So first of all, we know that this is a whole number. A whole number 1, right? Plus 0.3444. This and this are the same thing. Let me write equality sign here. And this also, we can drop it like this. 1 plus, we can write it as 0.3, right? Then plus 0.044444 that keeps on repeating. Can you see we are breaking it down gradually? This is the same thing as 1 plus 0.3 plus 0.4, but you have to divide it by 10, right? So now we are good to go. This is already a whole number. It is not a fraction. This is 1 plus. To convert this into fraction, you take 3, you divide by 10, right? To convert this into fraction, you take that 4 that keeps on repeating. If it is a single digit, you divide by 9. If it is more than one digit, you have to divide by how many number of digits that keeps on repeating. 999 to that number. But don't forget to divide by 10. We are moving. This is the same thing as 1 plus. Okay, let me even do it directly here. You know, this 10 is going to multiply this 9. So let me make it 90. So what will be the LCM between all of them? Let me rationalize this one. You know, divided by 1 will not change it. So the LCM will be what? 90. Because 1 can go into 90, 10 can go into 90, 90 can go into 90. Right? 1 into 90 is 90, and 90 times 1 is 90. Plus 10 into 90 is 9. 9 times 3, 27. Plus 90 into 90 is what? 1 times 4 is 4. Then all we need to do is to add all of these numbers together. Let me start from here. 27 plus 4 is 31. Then if you bring 10 here, you have 121, right? This is 121 divided by 90. I don't know, can 3 go here? If 3 goes into 12 4 times, there is no remainder. So we cannot divide 121 by 3. So our final answer is 121 divided by 90. So this is 121 divided by 90 as a fraction. I think I have covered all those set of numbers that reoccur but in a different way. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.